Now we're going to learn how to apply some of the tools in the last tutorial to actually processing data. In this tutorial, we're going to learn how to dead time correct your data and also normalize it to I0 stream, which is the number of incoming photons. For dead time correction, we're going to start with correlation plot. Go ahead and scroll down and plot ICR versus OCR. This is actually a pretty bad example because at say 8,000 outgoing counts, you can't really tell if it's 10,000 incoming counts or 50,000 incoming counts. So this is actually a bad example. But when you look at, if we map off the portion of the counts that are, or the portion of the points that are nonlinear, we can see that pretty much all of those extra high count points are located in a couple of regions that we just didn't anticipate in our sample. Likely barite particles, as we can see from looking at which channels have high counts in that region. Regardless, we're still going to dead time correct this data by selecting Analysis in the Correlation Plots window. Then select ICR versus OCR dead time. The program then makes an effort to fit any nonlinearity in your data. As you can see, it doesn't do an excellent job here, but it does help some. Then note the number that appears on the bottom left of the screen, the dead time number. Then go back to the main window and select Process, and then menu item Dead Time, and then Apply Dead Time Correction. In the window that appears, check the box Do Dead Time Correction, then click OK. Then go back to the correlation plotter and see that if linearity was achieved. Then go back and uncheck the Apply Dead Time Correction box because it doesn't actually affect your data. In order to actually do a dead time correction, you need to go to Map Math. First select a channel to dead time correct, then select dead time as the operation and rename a new channel. Then select Do Calculation, and then save it as a new channel. The new channel will appear as the last channel in the list, so you can scroll down to view it. If there's a substantial change in I0 during the time that you're collecting data, you may want to normalize your data to I0 stream. Here you can see that there are only small changes in I0 stream, so you may actually not want to dead time correct. The SMAK manual suggests that normalizing your data when the I0 changes by 15% or more during the course of your scan. You'll do this in Map Math by selecting the data channel that you wish to normalize. Then select Operation, Divide. Then select I0 stream as your denominator channel. Rename your original channel. Then click on Do Calculation. Now save that calculation. Your normalized data will now appear as the last data channel available in the list in the main interface. These two operations should get you off on the right foot when you're beginning to process your data. Please see the next tutorial for looking at principal component analysis.